Well, what do you say we start exploring the graphs of polynomial functions? And so here we have a graph on the right, and we're asked to describe the end behavior. And then we're going to determine whether it's an odd degree or an even degree polynomial. And the third thing we're asked to do here is to state the number of real zeros. Well, let's look at this end behavior. So I've got left end behavior. That's where that graph is headed in that direction. That's on the left side. And then I've got right end behavior, which is on the right side of the graph. Now, so let's see. And we've got horizontal axis, which is our x-axis, our vertical axis, which we ordinarily would think of as our y-axis, but f of x equals y, so it's our y-axis. And so on the end, my left end behavior, I can see that I'm headed into where f of x is approaching infinity. So I can say here on this end behavior, as f of x is approaching infinity, well, what am I seeing happening on the horizontal axis? Well, x is approaching negative infinity because x is going in this direction. Now, what about my right end behavior over here? Well, I actually see the opposite going on as f of x is approaching in negative infinity. In other words, my y values are going deeper and deeper into negative territory. X is approaching infinity. All right, that's not bad. We checked that one off. Now, determine whether this represents an odd degree or an even degree polynomial. Well, because the end behaviors are headed in different directions, I know that this has got to be an odd degree polynomial because my end behavior is headed in different directions. I would also know that this is a negative lead coefficient, but it didn't ask us that. And that's because it's left arm up, right arm down. If it was left arm down, right arm up, it would have a positive lead coefficient. And then lastly, it says to state the number of real zeros. Well, that's just where the graph, the real zeros is where the graph is crossing the x-axis. And I've got 1, 2, 3 places where we have real zeros. I guess we answered all the questions on that, didn't we? Oh, we'll learn a little bit later about terns. I see 2 terns in this, which tells me that it can at most have 3 zeros because the number of terns plus 1 would also tell us how many real zeros could occur, but I guess that's another lesson. Let's look at one more graph and then we'll head to the next chapter section. All right, so here I've got a graph, and I'm going to tell you right now it's an even degree. Why do I believe it's an even degree? Because it's end behavior. Here's my left end behavior. Here's my right end behavior. It's headed in the same direction. Now, because it's an arms down, it didn't ask us this, but I know that that's also got a negative lead coefficient with it. That's why both arms are down. But let's go back to the end behavior. As f of x is approaching, I'm going to write it like this. As x is approaching negative infinity, going in this direction, f of x is approaching negative infinity. And also on my right end behavior, as x is approaching infinity, f of x is approaching negative infinity. So we've described our end behavior. Check that off. We've determined it's an even degree. And state the number of real zeros. Well, I got two places where this graph crosses the x-axis, and so the number of real zeros is 2. I only have one turn in this graph since I mentioned turns in the other slide, which tells me that at the most I can have as far as real zeros is that one turn plus 1, which is 2, and I happen to see 2 here. Don't have to have two real zeros. I could have one, I could have none. But my terms tell me what's the maximum number of real zeros I can have. All right, well, we're going to go to the next chapter section, which I believe gets us a little bit deeper into analyzing the graphs of polynomial functions.